Hello, everyone. My name is Elton, and I'll be teaching the linear regression part of this lecture. So to sum up what Jahi and Nikhil were talking about with NumPy and NumPy for statistics, we're going to be talking about linear regression now. So in order to understand what linear regression is, you have to understand that linear regression is part of something called machine learning. And you guys have probably heard the term machine learning a lot now, but it's just using machines to kind of find out more about our data and to possibly come to conclusions about our data. So machine learning is a very broad topic. There are a lot of different branches to machine learning, and there are strengths and weaknesses of using machines. There are two main types which we'll be talking about, which are supervised and unsupervised. So the strengths are that machines are very good at following instructions, performing large amount of calculations without errors, finding patterns in quantitative data, and transforming data. So say we had a list of degrees, temperatures, but only in Celsius. And say we wanted that same list, but instead in Fahrenheit. So computers would be very good at taking in that list of temperatures and converting it to Fahrenheit, given a certain formula. However, there are weaknesses, which that they can't create their own instructions and that they can't create critically. So that's where humans come in, and we're able to supervise and give them the instructions that computers are very good at following. So here's a visual of the branches of machine learning. And here you can see unsupervised learning, and that's clustering, which we may or may not get a chance to talk about. But here's what we're going to be focusing on more, which is supervised learning. And within supervised learning, there's classification and regression. So if we're going to discuss the classification versus regression differences. So linear regression is more continuous data. It's data that's more on a scale or number line. And examples of which are temperature and height. Because temperature, it's no matter what unit you're in, Celsius, degrees, temperature will go through a certain scale. And so does height too. Whether you're in inches or you're in centimeters, height will always either increase or decrease. And certain numbers are bigger and certain numbers are smaller. So we're going to be focusing more on linear regression, but classification is also very good to know. And it's based on categorical data. And it tells you whether data is one thing or another. It can tell you whether something you put in is an apple or an orange, or it can tell you if it's like a sky or if it's an ocean. So linear regression, it's using a line to explain relationships between two variables. It uses one variable to explain another. So here, this is a data set that I'm going to be using later in our demo, but you can see there's a column for heights and a column for weights. So you can see that, people who are taller generally weigh a bit more, and people who are shorter generally weigh a little bit less, but there's no definitive relationship. But we're going to be able to solve that later. So there is an explanatory variable and there's a dependent variable. And explanatory variables often go on the x-axis, and dependent variables often go on the y-axis. So it's kind of a one variable depends on another kind of thing. So if one variable changes, the other variable will change as well. And linear regression works best when the data is highly correlated. We will also talk about how to tell whether or not data is highly correlated. So the important features of linear regression are these main topics here. So the correlation of data. How correlated your data is depends on how well your linear regression will turn out, because data that has no correlation can't really be defined by one variable. The slope of the linear regression is how much one variable changes depending on the other. And the intercept of our linear regression is just where our linear line crosses the y-axis.